We're going to have our last talk for the day. Teresa from DataWorks is going to join us and have a talk on their experiences in the context of contextual marketing. And she's going to talk about the post-deployment phase of an AI product. And I'm really suspicious, and have fun, guys.
Yeah, thank you for introducing me, and I'm happy to be here today. And you're lucky, guys, it's not going to be 30 minutes, it will be a bit shorter, because you already had a long day. So first of all, I actually have a question to you guys. I would like to think that you think about how many machine learning models did you ever train? How many of them did you deploy? And how many of them did you end up maintaining? Okay, actually you were supposed to see here a plot, which is highly skewed to training. So my assumption is that your plot, so this would be a long one and two smaller bars. So your plot would look similar. And this is my motivation why I want to talk about the maintenance phase of an AI product. And for this, I brought our contextual targeting, so an AI product. Then in the second part, I will compare the post-deployment phase expectation versus reality. And then finally, I will share my learnings of maintaining the contextual targeting. And our contextual targeting is a 3-year-old text classifier, and it's one of our products of our product team. So we are a product team of 5 people, 1 product owner, 2 data engineers, 1 data scientist, and me as a machine learning engineer. And this is just one of the products we are maintaining, and also we're developing new products. For instance, we just launched a new product 2 months ago. And this product helps us to answer the question, which ad would fit here? So you all know, if you didn't disable your ad blocker, that sometimes on some websites there are some ad spaces, and this is most of the time targeted to you. And this targeting, there are different approaches. So the first approach we have is the so-called cookie-based targeting, where you as a user are tracked across the internet websites. So in this case, for instance, you're looking for smartphones, so you get a tag, you're interested in smartphones, and then when you're entering a website, you will get an ad about smartphones here, for instance, Vodafone. So this is the traditional way. But as you all know, this will be history soon because the third-party cookie will die. And now comes our new product, or 3-year-old classifier, into play. And it actually has a complete different approach. So instead of looking at the user, we're looking at the website. So what is this website about? And as you can see it from the photo, for everyone who is not familiar with German, it's about puppies. So some advertisement about dogs would be appropriate here to show. So this is a point, the viewpoint from our customers and maybe you as a user. Coming now to our viewpoint as a product team. And these are the different steps we have in our prediction pipeline, quite a bit simplified, of course. And first, we will receive from our customer an API request containing a URL. Then we're taking this URL in order to scrape the website's content, like meta keywords, title, and description. And then based on that, we classify the website into 780 categories, and then sending this back. And this happens around 4 up to 8 million times per day. So this is near real time. So it takes an average like 20 milliseconds. And of course, this is completely automated and scalable. So it can scale down based on the new demand. Maybe in the night is less internet traffic, and scale up if needed. And is it moving? No, okay. And now you think, okay, as a maintainer, I don't have to do anything, and most of my day look like this, that I'm just hanging there, drinking a coffee, and maybe talking to someone, because the pipeline is fully automated. But in reality, there are many external factors which require to make some changes in adaptation to our pipeline. This could be new legal requirements, it could be some security issues where we need to exchange some components of our system, patch management. We got no training set data in order to optimize the model performance, and so on and so on. So, and if you have frequent changes, you also need to frequently deploy them. Thus, you want to have an AI product which is easy to maintain and easy to deploy. And of course, with over 4 million requests per day, you also want to ensure high availability. So luckily, we are not the first digital product having these kind of ambition and objectives. So what we can do is to transfer a lot of best practice and tools from system engineering, so from web or app development. The first one we're using, it's actually really hard to see. They're supposed to be like gray boxes, but I guess I can talk around it and you still get the context of it. So the first thing what we're using, of course, is code versioning, which is really important in order to roll back and also to maintain your product. And we're using Git in order to track Python code, which is our code for machine learning. Then we have our Java code, which we have for the ETL jobs, for instance, like the scraping. And then we're using additionally Terraform because we're using infrastructure as code. So we're using Google Cloud Platform, and everything is defined, every resource is defined in Terraform. And for deployment, we are using GitLab. And we have this typical step of a dev, QA, and production. So maybe some of you might think, is it like really useful because it's just like machine learning product and you know already the performance out of it? But actually it was already helpful in the past. For instance, previous colleagues of me were able to create a better model, but then they deployed it to dev and it was too slow. So they had to roll back, and this new model we had was never deployed because it was just too slow. Thus, having these 3 stages is also helpful for AI products. Then for the running system, as I mentioned before, our contextual targeting is completely scalable. So it can scale up and scale down. And this is because we're using these nice tools where we have the Docker file where our serving is in it, and the Google Kubernetes engine, which does the scaling, as well as Google Dataflow, which is scaling, for instance, the scraping job. And of course, another important component is testing. So we're using the typical unit testing, it's integration test, so if the API is really working with our customers, and also code standards, for instance, like Flake 8, where we look if the newly committed code is meeting our requirements. Because this is quite important, because you won't be the person maintaining probably the product for the next 5 or 10 years. So having these kind of standards is making it easier to maintain. And of course, you want to have a high servable code. So you want to have a monitoring alerting place. In our case, it's Google Monitoring combined with Slack. So Slack is our communication channel. So we just use Slack in order to receive alerts. And the most important part is, as I said, the documentation, because there's a high probability that you maybe train code and someone else will later have to maintain it. So you really want them to be able to get into the code quickly and maybe fix a bug or implement a new feature. And for this, we have 3 different levels. So we have in code, when we have, for instance, a complicated class or complicated pipeline, we have some description which are helpful. Then we have the README, which is giving a brighter or bigger context. And then finally, we're using Confluence. So Confluence is just something where you can write down some notes, where we have all the business logic. So we're having a model card, where we, for instance, write down what are the features, what you should know about it, like, for instance, like how many nulls are in it or stuff like this. For this, we're using Confluence. But you can also use every other too. It's just our standard. So those things are really nice and has been like proven in app and web development. However, hopefully you all know that an AI product is a bit different. So you have, so you can actually see. So you have more components. So you have the training, experimentation, you have the big data component coming in the model. And there's already something out there calling MLOps, trying to have also the gold standard, what we know from system engineering. But honestly, I think it's still the best because there are so many tools out there and you're not sure what to use, and you're can run in multiple challenges because every AI product is so different. So let me tell you about our story when we did the patch management for contextual targeting. So for everyone who doesn't know what patch management is, it's just upgrading your dependencies, what you want to do in order to close security gaps if you want a new feature, or maybe there was a bug which was then fixed. So that's why when you want to do patch management. And we're doing it every 6 months. And most of the time it's quite easy, but the problem is when you have a major update. And we had a major update, and for contextual targeting, because of how we built the system, we needed to do a retraining. And normally, if you want to just change the number of the Python package, you don't want to do like a whole retraining because it takes quite a lot of time. But this was actually the case because we had our model training repo with our requirements in it, which we changed. And then we fitted again the model pipeline. And then we picked the whole pipeline. So hey, pick a rig. And store this in a model store. And this was the problem because we picked up the whole pipeline, we made it dependent on the version on the Python packages. And we really didn't want to do that. So that meant when we also followed the rest of the stuff, we also had like a second repo where we had all the serving code because back in the days you had the training where all the training going on, and then later you had the deployment, which was 2 phases back then. But now it would be like 1 phase. Which built then the Docker and then updated the Kubernetes cluster. And then in the final step, the pipeline there would be updated. So this was our challenge number 1. And we solved it. We did the retraining. But of course, we didn't want to run again into the same problem, maybe in a few years or next year. So what we did in our improvement is that instead of picking the whole pipeline, we just pick up the weights and from the neural network and all the parameters needed for that pipeline. So our new process, when we had a major update, is now looking like this. So much simpler and faster and without pick a rig. We're all going to miss him. Not really. So to sum it up, here the learning was, try to have a version-independent model format. Don't pick up everything, just pick up what you need in order to roll back and have faster deployments. And here are some different version formats. Just stick into what would fit you and your AI product. So as I said, we needed to retrain. And this itself was, again, a bit of a challenge because we wanted to have the same model which was already in production because it was working fine and we were satisfied with it and we didn't want to start a whole experimentation process again. So in order to retrain the same model, you need the same data. Sounds simple, right? But actually we digged into. And first we found out that we have 2 different kinds of data. So we had our training data, the typical features and targets or /labels. But then we also had auxiliary data because it's a text classifier. So sometimes they're supporting files, for instance, like stop words, which we need for cleaning. So the right data is also needed in production, not just only in training. So if you want to have the same model, you need to make sure you have the right ones. And actually, the data set, so the training data, was 4 different tables in BigQuery. And by looking closer, we even found out 2 of them were adapted between the last training and us wanted to doing the retraining. So some data was added. And for the auxiliary data, we had 3 different text files, and 2 of them originating from BigQuery. So it took quite a while, but we figured out, and we had our data. But again, we implemented an improvement, which is data versioning. So as you all know, we are versioning our code, and it also makes sense to do it the same with data in order to be able to roll back if you want to reproduce our model. And for this, we used a nice feature from BigQuery, which is partition timetables, where you just have just per day like a data slice. So I can say I want to have the data from last September 1st at 3 p.m. So this will be helpful in the future in order to reproduce models. And also, at the same time, we, of course, refactored and made it simpler again for the next ones to come. So second learning, have some data versioning in place in order to roll back and have faster deployment. And here are some tools you can mention. For instance, DVC is nice if you have a large amount of data, but just look around, there are probably tons more of it. So the next challenge was, so now we had our data, so we were ready to retrain. We just needed to know what was the performance from the previous model. We did some digging and we found it. We found this nice line in a Jupyter notebook, having all the different metrics in a really readable way. And then the next challenge was to find the hyperparameters. And actually, there were 2 notebooks with 2 different hyperparameters. But luckily, we know the people who trained originally the model who could help us out which parameters we needed to know. But again, this took quite some time. So what I really recommend is even for production, it is important to have experiment tracking. It's not only important for the phase where you try to figure out which model is the best, but also having it later in the post-deployment phase. And what to version? So we are versioning the data and the model version. We have the hyperparameters and the metrics. And here at the right, you can see we are using MLflow. It's easy to implement. And you have the great benefit of also having a nice user interface, which would make it easy to compare the models. So have experiment tracking in order to compare and reproduce models. And here I listed 5 different ones, but there are even websites having 15 different tools in order to do experiment tracking there. Just dig into it and see which one is fitting for you. So the last challenge we have was when we wanted to do the retraining. We didn't want to do any experimentation. Basically, we just wanted to press a button and say, OK, retrain my model, and then upload it to our storage bucket. But the training before in experimentation was always done locally. So in order to do that, you needed to do the typical steps of cloning the repo, installing all the requirements, and then train it on your local machine for hours, and then upload the model manually in the model storage. Of course, this is manual and time-intensive, and especially the last steps is prone for errors. So what we did, we implemented this little guy called Argo, which is an automated workflow pipeline. So now instead of having the local training, we have it now in the Kubernetes cluster, and it's just one button or one line of code in order to train in. So here the learning is automated workflow pipelines that are really helpful to have it easier to maintain and a faster deployment. And again, there are a lot of tools out there which can match your needs. Yeah, those were the learnings, especially just for patch management of the contextual targeting. And now coming to the key learnings, what I learned in the last couple of months doing the maintenance. So the first one is you don't want to be this woman. You want to have an easy, maintainable, and deployable AI product, to have it as simple as possible and also as easy as possible to deploy. Then the next thing is we can draw a lot of good practice and tools from system engineering, so do it. It feels wrong, but it's good. Then the last one, as I said, from my point of view, MLOps is still really, really messy. So there are a lot of tools, and you have to pick a tool from it. Just keep that in mind. And then for the last point, today's right is maybe tomorrow's wrong. So you maybe pick here the wrong tool, which turned out not to be the best solution in 2 or 3 years. So just be open-minded to challenge past decisions. Yeah, and that's about the post-deployment phase of an AI product. Feel free to reach out to me via email or via LinkedIn. Thank you.
Thank you, Teresa, for the interesting talk. We don't have any questions yet from the audience, but maybe there's a question from you guys in the room by now, or maybe you can think about a question that you might type in online now. If not, there's one. Thanks.
Mm-hmm. So you as a team, what you use
So, I mean, you have more than one criteria. So criteria we use where, for instance, we're using Google Cloud Platform. So having a tool which can easily integrate with that is important. Another criteria was we are just one of, I think, like 5, 6, 7 different product teams. So if, for instance, for MLflow, another team was already using it. So we said, okay, let's use this one because then we can transfer their infrastructure as code, so the Terraform code directly to all their products, so it's easier to implement for us. Those were the criteria, and also another big one, it also depends on what kind of product you're using. So if you are developing a text classifier, an LLP base, if it's a XGBoost or linear regression, whatever you have in mind, it also depends a bit on that, what you need to store, because it's a large amount of data. You want to have something nice in place for that. Another question? Yeah, it's quite late. And bad air here in it.
Yeah, actually, we don't have another question from the online audience, but we do have a comment. Thanks very much. It was a great set of talks, and again, thanks, Teresa. I think so too. Your talk was great. Thank you.